Alright, welcome AP Stats. We are going to look at example 21, um, and this is talking about a manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing versus the current method of waterproofing. The appearance of the boots is not changed by either method. The company recruits 100 volunteers in the Seattle area, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of the 6 months, the boots will be returned to the company and will be evaluated for water damage. So describe and illustrate a design for this experiment that uses 100 volunteers. So there are a couple ways to break this up. Okay? And so when you get a problem like this, you want to kind of start going through the options. We could do a completely randomized design um, for the 100 volunteers, randomly assign them to the new waterproofing method versus the old, and see the wear and tear after 6 months. Okay, so the only problem with that that arises is that what if somebody's outside more than the other? So somebody who has, the old waterproofing is outside a lot more, and so the shoes are in the rain and in the weather more often than somebody who isn't. So now we don't just have just the difference in waterproofing, we have also a factor of how much are they outside, how much are the boots exposed to water that we're not controlling for. So the only problem with that is there's lots of other factors that can influence the waterproofing at the end of 6 months when you go to look at it than just randomly assigning them to one group and seeing how if one person gets new waterproofing, how that affects the shoes. Okay, so we have to consider something more than that beyond just a completely randomized design. So another design that we've used quite frequently is a block design. On a block design, you'd have to block people based on some characteristic that you know. So in this example, do we know anything about the people they recruited? Is there any information? Do we know their gender or their job or how often they're outside or any other information? We do not. So a block, you have to basically know some information ahead of time so that you can separate them based on gender or some other factor. We don't know anything about them, so you can't do a block design. There's one other design that we haven't discussed. It's been a vocabulary word, but we haven't done an example of. And what we're going to do here is this is going to be a matched pairs design. Okay, so matched pairs, there's a couple situations for matched pairs. You can be your own pair, okay, where one person experiences both treatments, and that is going to be a matched pairs design. Whereas you can also do a matched pairs where you pair somebody up who has similar characteristics, and one person randomly gets one treatment, the other person in the pair randomly gets the other treatment. So in this case, if we're going to do a matched pairs design, what you're going to do is that we want to have both the new waterproofing and the old waterproofing go through the same conditions for every person. So in order to make sure that that happens, we are going to assign them to have both types of shoes. Okay, so like you can randomly select some people to have the new one on the right foot and the old one on the left foot, and then do some people the opposite. Okay, so that every person has both types, both treatments. And so when each person is getting both treatments, this is going to be what's called a matched pairs design. So let's get that down here. We're going to do a matched pairs. So each person, in this case, gets both treatments. Okay. So if we draw this out, we're starting with the 100 volunteers. So what are the pairs? Okay, we need to pair them up. So is there another volunteer that we match with them? No, they're going to be their own pair, and what's their pair is their feet. So a left foot and a right foot is the pair. We're doing two treatments, so one's going to be on the left, one's going to be on the right, and we're just going to randomly decide who gets the left and who gets the right. Okay. So what we're going to do we have 100 volunteers, which is 100 pairs of feet is really what the matched pairs are. Those are the pairs. Each person, okay, is getting both treatments. So we're randomly going to decide if the people go to group 1, where we can say they get the new waterproofing on the right foot and the old on the left. Okay, or they could go to the other group where they have the new on the left and the old on the right. So we're going to have 50 people in this group. And 50 people in this group. So then you're just randomly deciding which type they get on which foot. That's the only randomization, but they're both getting both treatments, both groups, just in a different order. So what we're going to do then at the end is compare the waterproofing of boots. Okay, so that's an example of doing a matched pairs design again where you are your own pair. Something that comes up in this, a lot of people end up trying to block, so this is like a side note, on problems that you'll see in the future, so on quizzes and tests, a lot of people make a mistake of blocking by gender or by something else first. In a matched pair situation, where you are your own pair, or where each person is their own pair. Why is that incorrect to block by gender first if you are going to be your own pair? Why is that not required? Can we see why? Well, if everyone is their own pair, so for example, like in this boot example, if I'm getting the left foot new and the right foot old or whatever, I don't need to be blocked because everybody's already put in a position where they are their own pair. I am matched with myself. So I don't need to block men and women because I am my own pair, and so I'm a girl and a girl, that I'm automatically going to be doing the same treatment. So there's no reason in a matched pairs where you are your own pair to somehow block people by gender. You don't need to do that. Okay, so that's something we can talk about more in class, but you do not need to block first before doing a matched pairs. Okay, so for this boot example, could this design be double blind? So double blind, okay, blind, first of all, would be that the people don't know which type is which would be important, which type of boot they have. And then double blind means that also the people running the experiment who end up collecting the evidence would also not know if they're the actual, looking at the chemical makeup of the waterproofing or whoever's investigating whatever they're looking into. It would be, you could do that so that they don't know. Okay, so somewhere you have to keep record of which shoe is which, but you could always do that by like a digit or a code or something so that it's not obvious to whoever's investigating. Okay. So yes, this could be a double-blind study. So if the volunteers don't know which boot has the old versus the new waterproofing, okay, that would work. And so that's blind, and then the experimenter doesn't know which group got like left old, right new, or left new, right old. And so that's like a so basically, if the volunteers don't know which boot is which, and then the experimenter doesn't influence their decision, not influence their decision, but doesn't know which boot is which, so it can't influence how they're collecting the data. Okay, so this is an example of where you are your own pair. The next one that we're going to look at is where you're just matched up with someone who has similar characteristics as you, or the people in the study, not you in particular. All right, so researchers who are studying a new shampoo formula plan to compare the condition of hair for people who use the new formula with the condition of people who use the current formula. 12 volunteers are available to participate in the study. Information on the volunteers is shown in the table below. So the researchers believe that the condition of hair changes with age but not with gender. Describe and illustrate an appropriate design. Okay, so if we think this is kind of a key thing, that the hair changes with age but not with gender. So are we concerned about gender in this column over here? Not at all. We don't think gender is a factor. What we do need to control for is age. So we want people to be paired up who are similar ages. So we are going to take the 12 people and we are going to pair them up. And I'll just write this as like group 1. So we want to look at people who are similar ages. So when you look over here in the table, I see like age 21 and 20 look like they're going to be similar. If you look at these in order, there's nothing that's lower than 20. So we're going to group age 20 and 21 together into a group 1. So they're going to have similar characteristics because they're similar aged. And what's going to happen with the matched pairs is that you're randomly going to assign now one of those two people to the new formula, new shampoo formula, and then the other one will randomly get the current formula. It's important to note where I put the R's. Over here, when I took the 12 people and assigned the first 2 to group 1, was that random? No, it was not random. We set that group based on their age. So this right here does not have an R. This was not random. Versus when we go over here, we have these 2 people in a pair. We just want to randomly assign one of them to the new formula, one to the current formula. So this part, the assignment of the treatments, is random.